Hey there everyone, I've got a TK-941 900 megahertz radio, and today we're going to be trying to get this to work for digital modes using the MMDVM board. So we're going to try to use it to make it a hotspot to talk with a DMR radio or a P25. This is the 6580, a 900 DMR. This is the XTS 2500, a 900 megahertz P25, and we want it to talk to this TK-941 radio. So the 941, it's a pretty nice Kenwood radio. It does have a couple quirks. It's got a fixed 39 megahertz offset built in, so you can either put it in simplex mode or offset mode. There is a special ham firmware hack to make it a fixed 25 megahertz offset. The only problem is you're still stuck with 25, so if you have an odd split like 25.3 megahertz, you can't do that if you're using it as a user radio. It does make a perfect simplex node or repeater radio because you can just put it in talk around mode and you don't have to worry about any of the offsets. So you can put a filter in it for operation at 902. It's just, you got to replace the 936 megahertz filter. Even at 927, I'd recommend putting a 915 filter. It helps on sensitivity. And this is a 15 watt radio. So we've tried the 981 and the 931. They work well with MMDVM. This radio, it does work, although it's a little trickier to get it to work. So in this video, we'll be showing you the process to get the MMDVM board running with the TK-941. So the first step here is getting your radio programmed. You need the Kenwood KPG25D software to program this radio. A couple things you want to make sure you have set under edit feature options and go all the way down to mode. I just have all these enabled, so this will allow you to tune it from the front panel, because we're going to need to do some tuning on it to optimize it for the MMDVM board. Now, as you see here, there's no frequency entry. These are just my group names, just what the front panel displays. It gives you all these FCC codes. As you see the bottom of the screen, there's our frequency, and it's giving us a negative FCC code of -600. Well, unfortunately, you can't actually put that in, and you're going to have to run it through another piece of software. So for 935, that's FCC code 1, or 935.0125. If I were to go to 935.0250, FCC code 2, and so I just put a couple test frequencies in, 927.5, 9025, 927.0375, and then another test frequency in the normal operation band at 935. To actually enter in these ham frequencies, you're going to need to run the Kenwood 900 Easy program software, and there's tutorials on the Kenwood 902 website, so I'm not going to get into all that just on this video, but you're going to have to run that software with the code plug to get these FCC codes to a negative number to actually go in the ham band. Okay, so I've got 12 volt power applied to this radio. I've got the antenna connector going into my service monitor so we can do some initial alignment, and I've got the programming cable plugged in. I'm going to turn it on, and then I'm going to flash it with this this code plug that I made. So we're going to program write to radio, no password, and now it's writing to the radio. Okay, and now it's done programming. So I've got just a couple test frequencies I put in, and they're all set for simplex, so I'm not testing any duplex. I have not flashed the 25 megahertz firmware into this radio. This is just running the original firmware because I don't really care about those 25 offsets. The 25 megahertz firmware does change the tuning points though. It changes some of the tuning frequencies, which isn't super necessary for what we're doing, but it could be useful. Okay, so we're gonna get right into alignment. We need to enter tuning mode. So to do that, first power the radio down. Then we're going to hit the group up button. While holding that, press power. And now release group up. And now we're in tuning mode. So you notice there's two numbers. There's one under the system that we can change, and then group. For the system, this is our tuning channel. So there's several channels documented in the service manual. These are just different frequencies for the tuning. And then our group is the encoding signaling type. So when you actually transmit on this tuning channel by keying it up with the mic, what type of encoding is it sending? So 1 is carrier squelch, just sending nothing. 2 is 100 hertz square wave. That's for modulation balance. Let me bring up the service manual. So here are the different tuning channels, and I've noticed these frequencies are actually different in the firmware that I have, and there's only 8 of them, so I think this might be a newer firmware in this service manual. It doesn't matter as long as you can find what frequency it's on. And then here's the encode modulation types for each tuning channel. Okay, so on channel 1, this radio is on 896.0125. So we're going to leave it on this carrier squelch mode on channel 1 and then press aux to get in the different tuning settings. Or sorry, press scan. Squelch, this is a digital system. We don't care about squelch at all since that's all going to be in the MMDVM board. Power, so I'm going to actually lower this down just because we don't need a lot of power for testing. So I'm going to go, let's say 50, and then key it up, see what we're getting. Oh, I'm seeing nothing, so we went too low. So I'm going to go, let's say 80, 7.5. I kind of want to go down to like a couple watts maybe. Let's try 65. Yeah, that'll work. 1.5 watts, just so we're not overheating it for all the testing we need to do. Okay, and once you press aux to go into the next setting, that actually saves it. So I'll press aux, now saved. Okay, deviation. We're gonna be setting this with the audio level in the MMDVM board itself, but I would recommend going a little bit higher, somewhere around 150, just to give you enough audio level to set the deviation. Test. Well, actually it didn't get saved. Test. Okay, so I'm gonna go a little bit more. I think about 4 kilohertz. So you actually have to press aux to save it, unfortunately, or it doesn't get affected. So we'll do 170. Well, we'll do like 185. Test. Okay, and that should be enough deviation to give us for digital modes enough wiggle room. The next one is balance, and this one is super important. So I'm gonna hit the scan button to go back to the channel. Remember that 100 hertz tone? We want to set this for channel 2, for group 2. I'm going to go back to the balance setting, hitting scan again, and we want to go to our scope on our service monitor here. Vertical division, well, we'll start with 2 kilohertz, and then I'm just going to key it up. Yeah, we need more time per division. Let's try 2 milliseconds. That'll work. And this is supposed to look like a square wave, not this weird funky looking waveform. Now, I'm gonna start by tuning the balance here on the radio. We're gonna make adjustments, and I'll show you that later after the radio's tuned up. But first, let's just adjust this balance number until we get something more like a square wave. So I'm just gonna keep moving this around, and you can watch this waveform changing. So it's starting to get better, starting to look more clear. Okay, I went too far, now it's kind of curved, so let me back it down. Okay, that looks pretty good. I'm gonna call it good right there, since we're gonna fine tune adjust this when we actually hit the MMDVM board. The tuning it right here might not even matter because we're kind of have to tune it to this board anyway once we hook it up. So that's done. We wanna do frequency. We need to make sure we're on frequency, and I should have done this before I did deviation balance, but this will be fine. So we want to look at our frequency error, and we're pretty much right on. We're only off by 50 hertz, so no adjustment needs to be done there. And then last, I'm just gonna kind of sanity check on the receive. There's not really much adjustments we need to do because squelch doesn't matter, but I'm just gonna leave this here, and then I'm gonna inject a signal on its receive frequency, which is 935.0125. Just make sure we've got good sensitivity. And we're at minus 120. It's breaking squelch around minus 120, 121, so no issue there. Of course, the sensitivity will change in the ham band since I haven't done the filter replacement yet. In front of us, we've got the block diagram on the service manual for the transmitter system. This is the chain between the microphone and your actual modulation output. So the first logical place to start is this data input on IC205, and that's where I tried to inject it, and I didn't have much luck with it. It seemed like there was too much high pass filtering, and there's different circuitries right where these arrows are that aren't shown. And they were actually filtering out the low frequencies that weren't filtered out by this tone input. So I actually had better luck with this tone input right here than I did the data input, but it still wasn't great. I still had a lot of filtering and problems. I did also try the modulator input directly. Doing this, I had to actually build an op-amp circuit, and I had 2 separate 12-volt supplies and all sorts of crap with this op-amp. just to get enough voltage, because this modulator input needed like 6 volts peak to peak, which you can't even get 5 volts on the MMDVM board. Went down that rabbit hole, no luck. I ended up testing the quiet tone slash digital quiet tone, and this actually worked the best for me, surprisingly. You would think this is a PL tone input from the actual IC that generates those tones. You'd think it would be filtered out, but if you inject it right here in the IC212 input, you're bypassing a bunch of low-pass filters that this has, and this worked best for me. I think these low-pass filters balance the modulation out, and they're needed, so unfortunately you just can't hook directly into the modulation output. I've got this radio taken apart now, and I can show you where I got all the connections from. Starting out with connection 1, this is where I got the receive audio, the discriminator audio out, and the push-to-talk for transmit. This comes on your KCT19 accessory connector. So pin 2 here you can see is push-to-talk, and then the last pin here is DEO, which is discriminator audio. And ground, I'm just pulling off the chassis for now. Now the challenge was our input. This is the last input I tried that I had the most success with. I did also try tone on this. So this is the kind of the front before the control heads. The control head slips on like that. It goes on that connector. Anyway, so I was trying to pull off tone before. This is that last input where the actual tone comes from the synthesizer. I did try on this board, you can see MO modulation. This is where I had to build that amplifier circuit, had no luck there. And I also tried, there was another test point after IC6, after the DDA, directly on the VCO. That's inside this can. I did try an input here, but I had the same problem. So I ended up going right here where this capacitor is. I moved this capacitor down, I broke the connection. So this top pad goes to the CPU, which generates that PL tone. This bottom pin goes to that tone input IC. So I connected the audio directly to this capacitor, because this is a nice 4.7 microfarad bypass capacitor, so I left that in and I connected the MMDVM board. It goes right here. Okay, so I've got the MMDVM board now connected to the 941, and now it's time to calibrate it and see if we can get it to work. I'm going to start with this P25 radio, which I've got connected through an isolated T directly to the radio, so we don't have to deal with multipath and weird effects just by me waving the radio around. It's hardwired into this with enough attenuation. And now the first step here is we're going to start with receive, and I'm just going to adjust the RXN pot so we're just below clip. So you see I increased the level and now it's clipping. The clip LED turned on. Decrease it just so the clip LED's just not turned on. So we're good on RX level testing. So I'm starting with P25. I'm going to key up, and then I've got the MMDVM Cal software running here on the Pi Star. I've logged into the Pi and I'm running MMDVM Cal. And we're going to just start with a basic bit error rate test mode for P25. So that's option J here. I'm going to press that. And now we're on P25 bit error rate test mode. Okay, so I've just keyed up the P25 radio. You can now hear it on the receiver. I'm not seeing anything light up on the board, and nothing is showing up on this screen here. So our receive might be inverted. So let's do lowercase I, key it up again, and there we go. 0% bit error rate on receive, so that's really good. I'm not getting any errors at all. So to get the transmit configured, there's a couple more alignments. First of all is just the deviation itself, and we can do that on the DMR mode deviation set, and we need to set this to 2.5 kilohertz. So I press capital D and now spacebar to make a key up, and now this radio has a tone keyed up. And you can see we're a little low at 2.1 kilohertz, but it follows the FM bezel curve, so it's really cool because you can tune it on spectrum analyzer mode. And this middle notch is supposed to be nulled out. So I'm going to increase the audio here on transmit level. And then we can watch the center null as I increase the audio start to fall down. And now we're tuned up. Good enough. That is the deviation calibration set, but we still have a few more things to do. So now I connected the programming cable to the radio itself. Radio's in receive mode actually on the tuning software, and we're going to test bit error rate. Now this is a really important step, and you need to mess with that modulation balance setting in the tuner software here. So this step will take a lot going back and forth on the tuner. So first, let me go to the MMDVM software, or the MMDVM Cal. I'm I'm gonna go to A mode, which is the P25-1011 test pattern. So this sends out a constant tone test pattern for the P25 radio. So it's keyed up now, so we're transmitting at our test frequency. Now I go to the tuner software, and I've already read the radio here, and we're on bit error rate mode. Now we have to be on 935.0125. I've tried to hex edit this so much, I've just not been able to get it down to the 927. So I did put the radio in the test channel 1. Now the good news is the Moto Turbo radio tuner, you can hex edit and get it down, so we'll do that next. And when I do, so I set it up for 10 seconds, and let me start it, and now it's receiving, so it's gonna, 10 frames, so it'll be about 3 seconds, and look, we got a 0% bit error rate. So if I were to mess with it a little, so let me mess with the modulation balance a little bit. So I tuned the modulation balance just a little bit, and now you can see we just got a 1.09 bit error rate, which is not great. Tried it again, 1.07. When I initially started testing this radio, I was getting about a 12% bit error rate. So this is a super important step. And what I'd recommend doing is doing kind of a table like this, where you chart out your bit error rate with different modulation balance settings. So now I've got a DMR Moto Turbo 900 megahertz radio hooked up to this test jig, and we're gonna run the same receive bit error rate test to just double check that this is working for DMR. Now the good news about the Moto Turbo software is you can hex edit it into the ham band on the tuner. So the way you do that is, first of all, put a frequency you know here at the top. So I would put 935.0125 for example. Then you need to open a hex editor. I've got hex D, and you need to actually open up your tuner in the RAM. So then once you've done that, you do search and hit the replace button. It's the same way you would hex edit the regular CPS. Actually, I think you want to do 935.0000. Yeah, that's what you want to do. And then you just replace it with what frequency you want to tune. In this case, I'm doing it at 927.0375, and it'll allow you to enter in any ham frequency. Of course, the radio has to work there, but this will work. So yeah, just run hex D and use the same hex editing method that you do for tuning on the CPS, and you can run a bit error rate test. So now let's actually test the bit error rate. We're gonna then press M for the DMR simplex 1031 hertz test pattern, and then we're gonna turn the transmitter on, spacebar. So now we're transmitting with our radio, and then back to our Moto Turbo tuner. I'm gonna just press start here, and it'll start measuring bit error rate, and you can see it as it's doing it. Every frame it's displaying, and you can see we're mostly at 0%. We did get a little bit of 0.15, but our total average bit error rate is 0.03. So there could be a little of alignment, and I only really aligned this for P25. I didn't really do much with DMR, but it seems pretty good where it's at right here. Last but not least, it is time to test this on the air and see how this radio works. So I'm not going to bother putting this all back together. It's just for a demo, but I've got this on parrot mode, and give it a try. This is W0SKY testing parrot mode DMR on TK-941 12345 54321.
This is W0SKY testing parrot mode DMR on TK-941 12345 54321.
Sounds like it works pretty well. Let's try P25. This is W0SKY testing P25 12345 54321 on parrot mode test P25, and 0% bit error rate, so it looks good.
This is W0SKY testing P25 12345 54321 on parrot mode test P25,
and sounds good. So that was the demo / tutorial for the TK-941 series Kenwood radio. I do have about 5 or 6 of these radios as of this recording. So if you want a custom built repeater, whether it be All-Star, DMR, or Simplex node, I'm happy to help.